So I always watch myself go live, and it looks like I'm like a squirrel looking around, and people don't realize. Luckily, no comment has come across, but it's just this monitor that I'm trying to look across and make sure things are working. And I have to wait until I hear an echo. So I'm just waiting for that.
Are you sitting down or are you standing now?
I have a fancy setup, so I'm standing up. I have a standing desk. I got into that cult.
Does it help your back?
It does, yes. Yeah. Okay. Awesome. We're live, so I'll quickly start by introducing the session, followed by our speakers. Hi, everyone. Welcome back to Time Kaggle Talks. This is Time Data Science 2.0 because we get into more depth of, first of all, learning about the great guests that agree to come on here. Today, we have two incredible guests that I'll just introduce in a minute, but also about their solution. And today's talk is titled Moving from 1100th to 40th in the last 3 days of the competition. I remember I'm a noob Kaggler. So I remember every day I would submit, I would move up the leaderboard a little. That would give me so much rush. And I can only imagine the rush you guys would have had. So I'm really excited to learn how you felt during those weeks. So I've introduced the sessions a few times. This has been a running series. You can find a playlist on our channel. I'll skip that to be respectful of the guest time. And again, this is really Time Data Science 2.0. I'm skipping across because I'm excited to introduce the guests for today. So first of all, I want to welcome Vignesh Baskaran. He's at Tweet TV Baskaran on Twitter. I'm sorry, I wanted to put expert there. I mixed the profiles, but he's a Kaggle 2x expert and previously principal data scientist. Vignesh, thank you so much for joining us.
Thanks, Sanyam. But some mistakes are really nice to have.
I'm sure it won't be a mistake in a few days.
No, I'm pretty sure that the next slide is going to be a mistake soon.
Yeah,
that's going to be epic.
I didn't mess up here, thank God. Shahul, I remember I was just telling Shahul this off the record, but first time I interacted with someone from India on Kaggle, it was Shahul. So I'm really excited to have him on the talk today. He's Shahul786 on Twitter. He's a 2x master. This is a mistake because he'll be a grandmaster really soon. As you can see, there are 14 gold medals. Just want to go really close to that. I can only imagine what you're going through right now. And he has this incredible strength at the intersection of machine learning and NLP. That's the domain where he works on. We'll learn more about this. He's been a Kaggle addict since college. Welcome, Shahul. Thanks for joining us.
Thanks for having us, Sanyam.
Yeah, really excited to learn about your journey. The Indian community is slightly smaller on Kaggle due to some reason, but you all are really changing that. So that really makes me super happy, and I'm excited to learn about your journey. Before this, I want to point out the audience to a link. Let me share that link in the Zoom chat and in the YouTube chat.
Do you think it's a good time? Sam, do you think this is a good time? I share you the solution link as well so people can follow.
Sure, I'll post that in the YouTube chat real quick.
Yeah, perfect.
I'm gonna put this link in the YouTube chat. Please head over to this link. This should take you all to our community where we host the questions. So this should take you to this thread where you can find all of the links. You can connect with our guest. You can find their write-up and also a few dashboards that I'll be using for EDA because I'm quite lazy. And feel free to ask your questions here if you'd like. Since it's being live streamed to YouTube, I can't monitor the chat, so I'll just look at the questions coming in here. And that is how you ask questions after signing up. Awesome. Sorry for this. I have to do a 5-minute intro every time because I feel really impatient while doing that because I'm always curious to learn about your journey. The reason why I do this is you all have reached the 40th position on the leaderboard. Shahul is one of the top ranked Indian Kagglers. And I really want to know, how did you all do it? So how did what happened behind the scenes? How did you get started? So let me start by asking you, Vignesh, how did you get interested in data science, broadly speaking, and what made you join this? I think this was your first competition. So why did you join it?
Yeah. So, I don't know, like Kaggle is something that I came across it, I think 6 years ago or something like that. So I studied in India. I finished my bachelor's in Chennai, and then I moved to Belgium to study at the University of Leuven. It's a small country. But it's a beautiful city. So I chose to move there, and I studied my master's. And at the end of the master's, so I studied my master's in artificial intelligence. And at the end of the master, there is a university level hackathon that happens where everyone competes on a machine learning competition, and then it's for one day. And so at the beginning of the day, you get a problem statement, and then you participate and things like that. And that's the first time it was hosted on Kaggle, and that's the first time that I came to know about Kaggle. But luckily, I'm pretty sure you would probably know this guy, Ahmed Erdem.
Yes.
Ahmed was my classmate, and
oh no.
So, yeah, we studied
awesome.
together. He was the smartest of the university, as you can imagine. Anyway, so we studied together. We were in the same class, and we were really good friends. So we both competed in this competition, and that was the only competition where I did better than Ahmed. So I won the competition. Ahmed did not make it. Anyways, like 2 weeks ago, I met Ahmed, and I was jokingly telling him, your first Kaggle competition, you lost to me. You could be a grandmaster, but it doesn't.
So, yeah, Ahmed is an incredibly funny person also to talk to. He's been on the podcast, and he's very smart and funny also.
Yeah. So he has been on the podcast as well. So Ahmed, that's it. And then I'm a serious Indian boy who wanted to graduate and then go ahead and find a job and then be sincere at work. I was a workaholic. And so I joined a company called Darts IP, and I was the first data scientist of the company. So I had this chance. So I worked with my boss was the CEO of the company. That was one big advantage for me, that I did not have several hierarchies to go or something like that. So I had this opportunity to build the machine learning team at the company. So we built the team, and the first 4 years it was fantastic. But things happened. Some of our algorithms got much traction, and the company was acquired. So once the company was acquired, all of us made good money, but we did not have any more interesting projects. So I thought, okay, fine. 1 year, I did not do much with my life. So what more to do? And then I wanted to take a break, and I wanted to start my own company or do something about something like that. And that's when I happened to again talk to Ahmed, and then I checked his Kaggle profile, and then I saw he was a grandmaster. Then wow, now Ahmed is a grandmaster. Well, and then I thought, okay, why not try a Kaggle competition? And and that's how I started doing the CommonLit stuff. The thing was, I worked for an IP company, intellectual property company. So it was like we were very, very careful about our code and things like that. We don't speak we don't speak outside. We don't showcase anything outside and things like that. Everything was closed, and we don't publish code or something like that, because we were really, really careful about the competition and things like that. But you see, after coming out of the company, it was like a huge open space. And then I'm like, wow, so many cool data scientists around, and people are doing crazy stuff. And I cannot get to do I did build a lot of fantastic algorithms. We took over 100 algorithms to production, and it was fantastic time, but I couldn't showcase anything. That was a big problem to me. And I could not learn from the community as well. You see, when you have a problem, I cannot speak to anyone and ask for tips as well. all these things were going on in my mind. And then it was like all hell broke loose, and I was on Kaggle, and then I really love it. I'm really grateful that I happen to be a very small part of the Kaggle community.
So safe to say you've become addicted to Kaggle now? Has the Kaggle bug bitten you?
No, I'm addicted to the Kaggle community, yes.
Awesome. Shahul, I'll just come to your journey, but I have another question. So you've worked in the industry, Vignesh. You've put these incredible algorithms to production that were of great value. Is there a perspective change as you came to your first competition? People are always complaining. Some people, not Kagglers, of course, that industry is really different. Kaggle is really different. Do you see the value there?
Yes, it's really different. It's really different, yeah. But I'm going to be honest to you. Kaggle is not about solving problems. It's about learning from the community and learning together. So there are many more things that you learn on Kaggle that you would probably not learn in any industry. So here, I don't know, we all do this. We do this. Let's be honest, Sanyam, you were doing this podcast even before you were working for business. We all did it because we all felt a part of the community, and we had this community feeling that we learned together, had a problem, we sent to each other, and things like that. And so Kaggle is, I don't think Kaggle is just for machine learning. I think it's much beyond it. Of course, there are a number of problems that do not suit Kaggle's structure. Like, for instance, generative problems are not easy to measure and things like that. It's not easy, like you cannot conduct a competition easily and things like that. So there could be some shortcomings, and of course we definitely don't have 50 models in production. Just have one model in production in the industry, and even that model, maintaining it in production is very difficult. It's very different, but I think it's complementary. I don't think we should compare either of them. I genuinely think it's complementary. We need both. And Shahul is in the best place. He works in industry and still he's active in Kaggle. So I think that's the best approach, that in my personal opinion.
I've not Kaggled as much, and neither have I put as many models into production. So I really like how you said it's really complementary. But Shahul, I want to learn about your journey. How did you discover data science? Your first competition, I think you explored a bit. You tried an image one. You got your first medal, I think, in the Ashtray competition. How did you start your Kaggle journey?
Yeah, first of all, I envy Vignesh because I don't have such a wonderful story to begin with. I randomly landed in Kaggle during a hackathon, searching for a data set. That's how when I saw Kaggle the first time in my life. And then for some reason or not other, I went to Kaggle. I understood that there is a community like this. There is a huge, a huge branch like data science like this. So I just wanted to start learning and understanding what is it, and if I want to understand if that suit my career or not. And I started back in 2018 when I was doing my undergrad degree in computer science and engineering. I found so many great people in Kaggle, including the former Kaggle rank #1, Andrei Lukunin from Russia. So, I started simply chatting with him, and he actually mentored me a lot, and that helped me to encouraged me to start writing kernels. That's why I started writing kernels in Kaggle, and side by side I used to learn the theory, and in the other side I used to do the practicals in Kaggle. That's how I started my journey in data science. So currently working in fintech industry. I am very interested in the application of data science in fintech industry. And with this competition, I was actually aiming for a comeback to Kaggle since I was inactive in Kaggle since the start of the year. So I wanted to really come back to Kaggle, and with the overall contributions that I did to this competition, I think I'm back on track in my old style. So yeah, so I think I'm good to go from here. Yeah,
that's quite the comeback. You just rejoin and you're on the 40th position, just like that.
Right. Yeah,
that's incredible. how was your journey at that time? I remember I was in university as well when I signed up for Kaggle. I was just frustrated of the courses being absolutely meaningless and nothing making sense. Maybe
Right,
people
right.
had better experiences. I don't hate my college. I just hated the syllabus. How was your experience as you were learning these things? I remember you finally shifted towards NLP competitions. How was that
Right, right.
learning?
Yes. So I had such a wonderful friends community around me that all of them had something done extra out of their curriculum. So none of us was focusing on the curriculum, and all of us was focusing on something outside the curriculum, either trying to build something of our own or learn some special skill sets. So I was in this friends community, and I also wanted to learn something, and I also wanted to learn something out of the curriculum that everyone does. So I wanted to do something extra. So that's where I found Kaggle, and that's where I found my love to this data science. Initially, I started with data analytics, and I only used to do EDA then slowly moved to machine learning and started learning concepts of algorithm and machine learning. Eventually, I reached deep learning and currently doing natural language processing. So that's how it goes. And I'm very interested in machine learning operations as well, because the industry which I work in, I deploy models in production. So yeah, that's where I also like the industry concept of it. But yeah, it's not in Kaggle, but in the overall journey in data science.
Awesome. Yeah. So my next question, I think, to both of you would be, both of you have learned on and off Kaggle. How would you suggest someone should start their data science journey? Personally, I was also like very intimidated because I still am. Maybe I'm just scared of going to a leaderboard. I always feel like I don't know enough to compete in this competition. So any thoughts on that topic? Maybe you can start with Vignesh.
Okay. I think the imposter syndrome is a serious issue, and I think all of us fight with it. I mean, the time of superiority complex is gone. Now all of us are suffering from imposter syndrome. Yeah. Um, I will tell you honestly, Sanyam, because I was in the industry and because I'm older, much older than both of you, I learned something. It doesn't matter the position in the leaderboard or the ranks or anything doesn't matter. I'm sure I really respect many people in like the last 4 months of Kaggle. I met so many people, like not in person, like virtually, and I came to know about Rohit Singh, Maunesh, JC Skewer, and then the professor who works with NVIDIA now,
CPMP.
Chris Diot, Chris Diot,
Christian.
Yeah.
Chris Diot. All these people, it does like they never care about which position they are in. They are all in some of the competitions. They are at the top. Some of the competitions they are at the bottom. It doesn't matter. But at the end of the day, what all these people they contribute to the thing is fantastic. And I was always thinking before I joined Kaggle, of course, I was thinking that the competition's grandmaster is the biggest thing that one could ever achieve or something like that. But now I genuinely think it's the kernels. It's all about sharing kernels and discussion that is equally important. Or I would probably go to the other extreme and say more important than being a competition grandmaster or something. Like that's an extreme view. I agree.
You're telling me my whole life was a lie. I always thought competition grandmaster was the biggest thing. I'm just joking.
No, but I mean, because at the end of the day, it's not about which position you land in. Right? It's all about which position you help us land in. we don't, there are 200 and some competition grandmasters. We don't speak about them today, but we're speaking about Rohit, we're speaking about Mish, and all these people, although they have never been grandmasters. I think Rohit is a grandmaster now, right? Yes, I think Rohit is a grandmaster now. So that's what I really think. The leaderboard is the last thing that we should ever look at.
Yeah, that's great advice. I think everyone does fight imposter syndrome. I'm still in the phase of it being really heavy. But what resources did you find useful as you went about learning in your journey?
Can you, Sanyam?
Sure.
Can
So
you repeat?
what resources did you find useful as you were learning these things, and what do you recommend to someone else?
I would first recommend everyone to be active on the discussion forum. You have any question, you research a bit. Don't go and post it on discussion forum right away. Research a bit. And if you still do not manage to find a solution, then post it on the discussion forum along with the research that you did, and tell them, like, I did this research and this is what I figured out from it, but still I'm not able to figure out the solution. And a lot of conversation happens on it, and people really appreciate when you do a bit of research and then post it on discussion forum instead of not even doing a Google search. And that's something like that. That's one thing that I learned. Or if you struggled with something and you found the solution, still go ahead and post it on discussion forum, because it could be helpful to someone else. So I think discussion forum is one of the most important things that really helps us. I also think watching the talks from Kaggle community people, many people post talks. Chai Time is one of the examples of that. I also know Abhishek hosts some talks with that. I think when you look at them and when you listen to them, you also understand that, okay, they're also normal people like us. They're approachable or something like that. And one of the most, I genuinely think, one of the most respectable communities is Kaggle community. People don't shit post, and people don't, you see, people are not arrogant. People try to help very much. So I think for me, I would definitely say do your homework and go to the discussion forum and slowly get started. I have never done any playground competition because I was already a data scientist for 6 years. So I straight away went to CommonLit. On the other hand, it depends on which competition you choose. Use the discussion forum and don't be shy. It's okay. All of us don't know certain things.
Yeah, it's people don't realize, like, whenever as I went through your write-up, this is always something that happens in every write-up. We're thanking each other. We Kagglers are thanking each other because everyone has shared their solutions, and we're just like building on top of these building blocks that someone has shared, and then further people share it furthermore, and it's mind-blowing at first time you realize what's going on.
Yeah.
Awesome. Shahul, same question to you. How did you go about learning to becoming one of the top ranked Kagglers? What resources do you recommend?
Yes, I second what Vignesh says. It's not about getting medals or winning competitions. It's about the whole environment that Kaggle provides for the development for data science enthusiasts. So, be active in communities, get in touch with people, talk to new people. You have 100 ways to get in touch with someone if you want to do it. And always start. I would say, do your research. Go to discussion forums. Try to publish a notebook. Don't get upset if your notebook does not attract traction, because if you look at the initial notebooks of some of the Kaggle grandmasters, you will see the same. So it's about getting that review from people around in the Kaggle environment, and understanding that review and taking that review and putting it to development again. So I believe what the whole infrastructure, that the whole environment that Kaggle provides is awesome. And to start with data science, it's a really good platform with the recent ML courses and all that Kaggle itself provides, which was not available back when I started. So all these resources help enthusiasts start with the community.
Yeah, that's awesome advice. Did you? I know we both have discussed this on the forums, and we both are upset that some people tend to overshare their like. It's called upward begging. That's what it is literally. But you've done this really nice job of sharing what you've learned. So have you found it useful, your Kaggle progress in your career, also as an
Yes,
attractive point?
yes, of course. This was a very attractive point in my career till now, because I haven't applied for any jobs till now, because all the jobs that I did, even the freelance works and everything, that has come to me. So it's I think it's mainly due to Kaggle, and of course I have some contributions and work in blogs in open source as well. But I think the main attractive point for me and my profile is Kaggle, and also the of course the network that I built through Kaggle has been very useful for me in my career.
That's, yeah, it's difficult to explain how much Kaggle can change your life. That's I've
It's very difficult to explain. When I started back in 2018, I never had this. I never thought I would end up being interviewed by Sandyam. So this it's the perseverance that changes everything.
you being too kind. I asked my first few questions to you on Kaggle forum, like I said. So I never thought I'd get the chance to interact with you. I remember I saw the Aladdin icon and orange ring to it, and I was just thinking, oh my god, just some master has replied to me. That's incredible.
Right. I was a student back then.
And you were already on the top of the leaderboard, so your journey
Yeah.
has been incredible. So that
Sure, thank
I
you.
think that was the end of the Q&A. What I'd like to shift towards, and there are also general questions that I ask around this, because I like to understand how did you approach the competition, what was going on in your mind. So I'll just start by introducing the problem statement and the data set by shamelessly using dashboards that a few of our ambassadors have built. And please feel free to interrupt me anytime if I mess up. So we've already had Anjub Syed. I did introduce the problem statement there, but I'll quickly go through it. The challenge, as I understood, was to help this institute called CommonLit understand and rate different essays for kids in grades 3 to 12. They use some weird metric that I couldn't understand at all. Apparently, it doesn't make sense to use it. So that's why they want to use machine learning to really optimize what they're teaching the kids. So I think that was the general problem statement here. And since we are predicting this number, the evaluation metric becomes an RMSE value. I was thinking it might be Jacquard index, it might be something else. But because of that, it took me a second to figure out, but it was RMSE. One thing I like to do here is I'm quite lazy with the ED. I'm not as good as Shahul. So Kaggle recently introduced this. So I just click on compact and that really shows me everything around a column. So I usually start there and I'll use that as a cheap way of introducing the data set. But it had it had IDs for every single sentence or paragraph. For some reason, there were also URLs of Wikipedia. I don't understand why you would teach someone from Wikipedia in grade 3, grade 5. Those are like really complex text. There were some licenses, not everyone was populated with the license. Finally, you had the excerpt and the target, and I'm trying to see the name of this column. The standard error. I'm sorry, I don't understand what the standard error was. Maybe you can elaborate on this, Vignesh or Shahul.
Yeah.
So I'm just.
Yeah. Shahul, you want to go ahead?
I was saying eventually when the competition started, none of us understood what was the standard error.
That's really helpful. But what did it stand for, and what's being shown here?
So they have calculated this target using Bradley-Terry method. And when calculating all these scores are generated from a set of labeled data which are labeled by a set of users. So after the set of users do not label the data as a score. They label the data in comparison with another sentence. So there is sentence A and then there is sentence B, and the labeler sits and see if the sentence A is easier to read than sentence B. So it was made as a binary label, and then to convert the binary label to a regression target, they have used Bradley-Terry, and while using Bradley-Terry, you get a standard error. That's the standard error.
Yeah, in our solution walkthrough, we explain it.
Awesome. I'll just come to that afterwards. That's it.
Okay.
So what I'm going to do next is I'm going to use a dashboard. I think this was built by Ruchi, who's a Kaggle Grandmaster and also one of our ambassadors. It's a nice dashboard, so that's why I'm using it. It makes my laziness reach its epitome, but I'll quickly point out different things I learned. She also created trigrams, bigrams, and unigrams of different words. Maybe the kids are being taught, let me zoom in a bit. Maybe the kids are being taught about environment. So it's great to see carbon dioxide, similar words. They're learning about New York. I don't know from what country did they source this. So if it's from India, they're learning about overseas countries. Unigrams didn't have any interesting words. I think these are just simple words that I saw. The average word length distribution, as I see, was quite similar. So not many different or weird sentences that would stand out. Most of the licenses, at least the one that were annotated, were CC by 4 is the most open license as I understand it after MIT. So it's really free to use. I'm just trying to set the stage here for different things as I just go through them. So I'm trying to point out different things that sound interesting to me. So please feel free to point out anything else. Yeah, I think I just wanted to point these out that the sentences aren't too different. The average word length is quite similar, and the character count distribution isn't also too weird. It follows a standard bell-shaped curve, if I may. Do you have anything to add for the EDA bit or anything else that stood out in the data? Okay. Awesome. Let's move on. So I'll probably pass this back to you now. I'd love to understand. As I understood, you both started separately in this competition. So maybe Vignesh, how did you first, when you saw the problem, what came to your mind? How did you approach the problem? How did you spend your time?
Okay, so yes, Sanyam. So I did not know about Shahul the first 2 months of the competition. So yeah, so I did not know about transformers. I mean, I knew about transformers, but I had never used one until then at all because I was deep into image recognition stuff. So the first 3 years of my work, I built a lot of NLP models. And we used them internally for cost cutting, but we never sold it outside. Whereas, and then the 4th year of my work, again, I prepared an image recognition system. It was again for internal work, but what happened was some people outside work came to know that we are using such a system and they wanted to use it as well. And then it became a big hit. Everyone in the market wanted it. So I was completely lost in this image world. So I had no idea about transformers at all. So the state of the art that I knew 4 months ago was a recurrent neural network for text. I was like, okay, I came and then people were all using Hugging Face transformers. I did not know what is this Hugging Face. It was really weird. Then I decided, okay, I'm not going to get into this wave. I cannot do it. So I'm going to do what I know to do. So I started with scikit-learn. I started building simple random forest and then a linear regressor and then an SVM regressor and things like that. I slowly started adding it up. So I was all working with bag of words. And then from bag of words, once I reached the peak and I knew I could not improve anymore, then I took the spacey vectors. So I take the sentences, so each document, send it to spacey, get back a vector corresponding to the spacey vector. And so spacey, I used it as a black box. I don't care about how spacey generated a vector for each document. I did not care about it. So, and I was working on top of that. And once I hit a certain ceiling, then I removed the spacey out of it, and then I replaced it with a Hugging Face transformer. I used a pre-trained transformer as a feature extractor. So the same way as how I used spacey, I did the same. But with spacey, I jumped up way ahead when I replaced spacey with the Hugging Face transformer, and that was the thing. So, and then I realized, okay, I have everything in the pipeline. I have a frozen transformer, which I use as a feature extractor. And on top of it, I have an SVM regressor, and it is giving me a target score, and I'm optimizing it for RMSE. Once I had all these in the pipeline, and then I thought, why not train the transformer? So so every notebook that I develop, I posted it on Kaggle, but of course it doesn't have much traction, because who in the world wants to use an SVM when you have a transformer? Anyways, it didn't. So some grandmaster guy, he came and he commented that, oh, you have a really nice code, but maybe you should try to train the transformer. I was like, oh, okay, now maybe training the transformer is going to be interesting. So I trained the transformer, and then I went way up in the leaderboard after training the transformer. And the next time, so I that's when I came across, I was very happy that I climbed up, and so I had an error rate of 0.53. Okay, and then I saw Maunish had done a very similar notebook, but he had an error rate of 0.48. And in these competitions, even 0.0001 matters a lot. And now I was 0. I was like, how the hell can Maunish, who has the same network like me, and he does the same stuff like me, scores so much higher? So what I did was, for 1 week, I went crazy. I took Maunish's notebook, I re-implemented it myself. I took my notebook, re-implemented it again by myself, and then I compared everything. And then I found the trick. There was just one single trick that Maunish was using, with which he went way ahead. I used the same trick, so it was one single line as well. So I used that one single line, and I went up.
What was the trick? What was the line?
So he was validating every 10 iterations instead of after every epoch. This is actually something very, very weird to me, coming from an image recognition world. So what we usually do is, we have a trained data loader, we have a valid data loader. We train the model for one epoch. Again, we validate it for that epoch, and then see how the performance of the model is. And if it's best, we save it. And then we go to we do it, right? Now, for each epoch, there are about 800 iterations or something like that. No, 200 iterations or something like that. I saw Maunish was evaluating every 10 iterations, and he was choosing the best model based on every 10 iterations. And that is the thing that he was doing. So I just, instead of evaluating every epoch, I evaluated every 10 iterations, and I reached the same performance. Anyways, that's not a good thing, because now we are, it's like shooting in the dark. You're trying, you have 1,000 apples thrown up, and you have a random knife going and hitting one of the apples. That's normal, right? It's no magic. But that is what was happening. But that is what people were doing, and I noticed it. But anyways, I used it, and then I went up the leaderboard. Then I met Shahul, and everything changed.
That sounds really dramatic. Shahul, what was happening before you met Vignesh? How did you approach the problem?
So I started the competition in the second month, I think, and I was trying to make a comeback, as I said. So I saw this guy Rohit Singh publishing so many notebooks and everything. So he had published a list of concepts which I do not know. even inside the transformers, like differential learning, right? A lot of stuff that he published. So I was searching around, learning all these concepts for first, three weeks. I spent all the time like that. Then I started delving into the discussion forums, where I found again people sharing a lot of stuff. In between, I wrote a couple of kernels and shared them. Uh, and also started being active in discussion forums. Then I saw this guy, Vignesh, sharing almost all the tricks here and there. So I was also not in a, I mean, at that point, I was also not in a mood to compete towards the leaderboard, but I wanted to, make that comeback, start that learning process again. And then I thought, yeah, I think this guy is in the same mood. He's not, interested in, running towards the leaderboard. So I spinned up a conversation with him, and yeah, the rest is history then. So things synced up well between us. Later, uh, we teamed up. Later, we teamed up, and yeah, we did like lot of experiment, and yeah, that's how things went for me.
So, first of all, why did you decide to make everything public, Vignesh? As you were learning, why did you want to share it? Why not keep it to yourself and keep the secrets to yourself?
Okay. There is a very deep personal reason why I did not do that. It's because I told you, right? I was working for an intellectual property firm and things like that. It was a very closed environment, and I was like, Sanyam, in real life, the main reason why people hide stuff and they don't share tricks or something is because they want to make more and more and more and more money.
Yeah.
And for me, after a point in time, I started suffocating. And for me, it was hiding stuff and doing stuff and not sharing and not speaking openly. You go to IP conferences, you cannot speak openly with anyone. And the other person on your side is also not speaking to you transparently. Growth doesn't happen. And for me, I realized it very clearly. And then I came to Kaggle, and then I realized I'm not going to do the same mistake again. Yes, I made how money is over there. That's how here you have winning points and things like that. I'm not going to do that. I am a part of this community. I'm going to embrace in this community, and I'm going to develop in this community. And I'm just thinking about this, Sanyam. What would have happened if I hadn't shared my code publicly? I wouldn't have met Shahul. I wouldn't have. It's maybe we would have ended up in different. I don't know. We would have ended up in different places in our life or something like that. But at the end of the day, I met Shahul, and we ended up being very good friends. Just because I did not have this attitude of how do you call it, as like being opaque and being for myself, being very how do you call it, as I don't know the right word for it, but being not transparent or something like that. At the end of the day,
in a way,
at the end of the day, what happened was Shahul learned, I learned, the community learned, everyone got benefited. And because Shahul and I were very transparent even in our final solution post, that we landed up here mainly because of those 8 to 10 people whom we mentioned the names, and all the other 5,500 participants whose name we did not mention. That's the reason why we ended up there. So this success is because many people sharing their code, many people sharing their discussion and things like that. And very importantly, here I would like to speak about someone. It's a Japanese name. I do not remember the name, but I don't even know if it's a man or a woman. Okay, what happened was, I'm going to find the name and I'm going to tell you. So this person, 2 days before the end of the competition, actually told me about. So I'm going to Kurosh. I think. Shahul, do you remember the name of this person?
It's hard to remember.
Please feel free to share your screen. I'm sure we can recognize them by the profile.
Okay. So I'm going to try to find the name. Or how can I share my screen?
If you just hit on share screen.
Yeah, okay. I found it. There's an option called share screen.
You need to select the right window as you do, and then just share.
Okay, there is Chrome. I will share Chrome. Do you see my Chrome?
Yes, I can see your write-up.
Okay, Kurupikal. Okay. Kurupikal was the person. So Kurupikal Kurupikal was already in the top 5 or something like that, and Shahul and I were around 1,100 or something like that. And Kurupikal told me a trick. So he or she posted it on the forum that, look, if you use this trick, your problems could be solved. But what happened was, and then I did not. So I tried the trick, but I couldn't use it. But at the end, what happened was, I found one of the old discussion posts that Kurupikal had posted, where he or she told about a particular thing that worked very well for him or her. Okay, that particular trick did not work for me and Shahul earlier. So what happened was, I saw, okay, fine. So this works for her or him, but it did not work for me. So what I'm going to do right now is I'm going to go retry it and get it working. And I got it working. And that's one of the reasons why we climbed up way ahead in the leaderboard. So things like this, where one helps the other person and all of us feel happy for it, is what is one of the main reasons why I did it that way.
Yeah, I think that can only be experienced as you join a competition and you learn through these wonderful people like Vignesh as he shares his kernels, or like Shahul as I hope he continues writing after he becomes a grandmaster, but as he learns through his kernels.
Sure.
Awesome. So I'd like to continue by diving into your solution. I just understood how did you approach the competition? Why did you team up? Would you like to continue walking us through, or should I do it?
Yeah, so my screen is frozen. I'm trying to see what I can do about it.
Let me see if I can stop it from.
I think I'm going to leave the call and try to join back. Is that fine?
I can stop the sharing from here.
You can stop the sharing. Okay. Okay, so perfect.
Let me share the solution right up. And this is the thing with live sessions. Everyone gets exposed to a little behind the scenes as we debug these issues.
Okay. Maybe awesome. Can you? Okay, no. I sent you another write-up from a GitHub post.
Sure. Let me.
So you put on that tab on the right.
Right. Yes. I have a few tabs open, so I'll just get confused.
Yeah. Perfect. Okay.
Awesome.
Okay.
So you've introduced.
Okay.
Please continue. I was just going to do the walkthrough, but please take to it.
Yeah, okay, no problem. So maybe let Shahul start. I'm going to close the window.
Sure.
So I quickly skimmed through. I believe you introduced the objective and the competition. I'll skip past, and the scores. I did not realize this, but the scores range from -3 to 2. I'm guessing it again depends on how readable it is for different grades.
Yes.
So
okay. So
Please continue.
Shahul, would you like to start, Shahul?
Yes. Right. So, yeah, we have the competition data here, and the competition data mainly consisted of the excerpt, which contains a text to be rated, to be rated, and then there is a target, and yeah, and then there was this standard error, yeah, which signifies the standard error in Bradley-Terry model. If you see the histogram of the scores, you can see that it's like a normal, it's distributed like normally, and yeah, and then you have different ratings for text. So the very easy text is rated towards the positive, and you can see that you can see a very easy text here, which is rated almost almost 1.6, and then there is a very difficult text down there, which is very negative. So this is the this is
I
what
wouldn't read this in high school. The light year units used to
right.
express astronomical distances. I would just give up here. Sorry,
Right.
please continue.
So this is what the competition host wants us to predict, and wants us to build a model to predict on. And yes, then there is two approaches to split the data. So firstly, that
Shahul, I would like to add something here because Sanyam told, Sanyam, can you please go to the top of the notebook?
Absolutely.
A little bit above. Yeah, here. Here. So I would like to briefly discuss about how did these magic numbers came, the target scores from -3 to 2, how did it get computed? Actually, Bradley-Terry, I spent a couple of days in trying to understand Bradley-Terry, and I implemented it on Python by myself. So I understood how the thing worked or something like that. So Sanyam, can you please go to the screen?
Sure.
Yeah, thank you. So what happens is there were about 100,000 text snippets in the competition data. And no, there were about, 6,000 text snippets in the competition data. But only around 3,000 was given to us, and the other 3,000 wasn't given to us. Anyways, the 3,000, what they did is they randomly make pairs of text. So, for instance, if someone gave you a single piece of text and asked you, can you say if this is easy to read or difficult to read? You cannot say it's difficult. Whereas when someone gives you two pieces of text and then says, can you tell us which one is easier to read? Then you can read both of them, compare, and easily identify which one is easier to read. So what happens is, out of this 6,000 text snippets, they randomly made pairs and gave it to multiple examiners. And they asked, can you read these two texts? Then say which is easy, which one is difficult. So what happens is, it becomes into a binary classification problem then. So that is what happens. Now, once they did it, there is this mathematical formula which actually basically works like a logistic regression. So you can take in a matrix of comparisons. So a matrix, yeah, maybe there, Sanya, please. So you can take up this matrix. So where I is a particular text and J is other text. You try to compute.
Are we looking at this formula? Sorry.
Exactly. Yeah, exactly. So what you try to figure here out is, what is the probability that the text I will be rated more difficult than text J? That's what Bradley-Terry computes based on these pair of classifications which the examiners did.
Right, that makes sense. So we have different examiners rating the text. Then we take this, put it into a probabilistic model that compares this, and that's how we get these ratings. Did I summarize that correctly?
Yes.
That's
so right. Yeah. So it's like, writing teams in a tournament. So
Hmm.
in each game, a team plays with another team, and then there is a binary label if which team won that. And then at last, if we want to assign scores to each team, we have to make this binary labels to some scores using some probabilistic model. So that model here is Bradley Terry, and yeah, that's how they finally ended up rating each of the texts.
Makes sense. And I'll probably come back to this, but it seems like you've also created a library for just this
Right,
walkthrough.
right. So yeah. So for this competition, what we did was we had a list of stuff to experiment on, and 90% of the stuff we know. I mean, we know that 90% of the stuff we have written down won't work. So we obviously that's how Kaggle works. So
Yeah.
so what we did was we created a library, a small a small library which is which is very flexible, and this will serve as a template to us. And then we once we have to change something, we only have to change it in the configuration file. So we just change once we have to move from one scheduler to other, we just change it in the configuration file, and that's all done. So we built this CommonLit NN kit for that purpose.
That makes sense.
Yeah, Vignesh. Yeah.
Okay.
Continue.
Okay, perfect. Okay, Sanyam, can we please go down a little bit?
Sure. Also, before we go on, could you please explain maybe to the beginners why having this normal distribution is important, and why does everyone look at making sure it's normally distributed?
Can I go about?
Sure.
Yeah, perfect. Okay. So one of the things that one of the implications of having this normal distribution, you see everything that we everything that we model is some kind of we kind of have an assumption that it has a normal distribution or something like that. So in this competition particularly, it's kind of very interesting that we had to really make sure that we have a proper normal distribution, mainly because let's take up a regression problem, and I don't know, I'm not able to explain it clearly. Okay, so maybe Sanyam, can you go a little bit down, and we are going to explain a little bit of the implications of this distribution and how we split the data based on this distribution, so we can understand it even better. So there are two techniques by which, stratified k-fold splitting and simple k-fold splitting. Okay, so there are two techniques by which we split the data. Basically, because the given data was very small, about 2,800 samples, we had to split the data into 5 folds. So each fold consisted of equal number of samples. Okay, and what happens? So what is the difference between a stratified splitting and simple random splitting? Is the fact that when we do it in a stratified fashion, we take into account what is the distribution of the label, the target label, and then we make sure that the same distribution exists in every single fold of the data, so that when you train on a particular fold and then predict on another fold, you can make sure that your model has had a fair chance of looking at all the possible kind of data when it is getting trained and when it is getting tested as well. So this is some kind of a logic that make sure that you train your model in a fair way. So now let's go back up. Okay, so Sanyam, now what is your question?
Yeah, I was just trying to understand why the normal distribution is important, just trying to get that point across. But yeah, that makes sense. As we create these buckets or folds, we would want to make sure that every fold has a uniform distribution. And since it's already there, we don't have to worry too much about it.
Okay.
Awesome.
Right.
So
I'd like to add on a point there. So
please.
As this was regression problem, and stratified k-fold and simple k-fold by default, we use them in classification problem. That we had to improvise a bit so that we can use the stratified k-fold on regression problems. So we found the community found an old competition in which we had the same issue, and we actually ended up splitting the regression targets into different buckets and then stratifying on the buckets to get a proper stratified folds.
That makes sense. Okay, continuing
So
further.
One of the things that I told you, Sanyam, that we learned from Kurupikal 2 days before the competition, end of the competition, was training it on external data. So what happened was, Shahul and I, we assembled a lot of external data. So we decided we are going to approach it in this way. We have 3 models to be developed. One was a Roberta base. So Roberta was one of the best performing transformers that we learned from the forum. So we used Roberta base. So one model is going to be trained with the Roberta base on the competition data set that was provided by the competition host. Another model is going to be trained with Roberta large, again on the competition data. And then another model, again, we will train it with external data. So these were the 3 things that we had in our mind. I'm going to reason out why did we have these 3 things in our mind. The first one was because training Roberta large takes a lot of time. So to train a 5-fold Roberta large on Kaggle GPU, we had to spend at least 3 hours, I think. If I remember it correctly, it was around 2.5 hours to 3 hours that it took to complete one model training. And you, of course, know, after training one model, it's not going to work. So we had to do it over and over again. And so what happened was, Shahul and I decided that Shahul will be responsible for training Roberta base models. So he's going to experiment with parameters on Roberta base, and then figure out which parameter, which combination works well, and he will tell me, and then I will run it on Roberta large. So this is what we understood in the beginning of the competition. This is the decision that we made consciously because we were naive and we thought that the learnings from Roberta base will be transferred to Roberta large. But that's not true. Whatever you learn from Roberta base need not be true for Roberta large. This is something that we realized as the competition progressed. Anyways, the other thing was,
I was just going to point out that 3 hours feels fast, but that's like a lot for just 3,000 examples. So that puts it in context.
Exactly. Yeah.
Right.
Exactly.
And the 3 hours is for k-fold training, I guess. So you have to consider, we are training the model 5 times.
Yeah.
Yes, makes sense. Yeah.
And so because of the size of the data set, we decided we are going to pre-train our models on some external data. So basically, to people who are new to transformers, why does transformer shine is because of transfer learning. You start from a very good initial point where your model has already been trained on another related task very well, so that your model already has an understanding of language. So you don't teach English to the model anymore. The model already somehow has a sense of the language English itself. and things like that. So from that point in time, you start training it on top of it. So it's something like how we go to high school, where all of us are exposed to a certain knowledge in all the domains. So we know quite well about how to study all the domains a bit. Whereas when you want to specialize, you go to an engineering course or an arts course, and then you specialize on top of it exclusively on that. So that's how transformers work as well. Although in India, we always go to engineering school.
I was just going to say that. But no, that's a really nice.
We are all fine tuned for engineering.
Yeah, exactly.
Yeah.
But we thought, let's do the same. But the challenge was, because this competition had this weird target, which it's not interpretable, we really couldn't find an external data set which consisted of the same kind of targets and things like that. So what we decided was, we will probably take up but if we look at Bradley Terry, how Bradley Terry works, it takes pairs of text and compares the text and then tells which one is better and which one is easier to read and things like that. So Sanyam, when he introduced the Explorer EDA, he spoke about the URLs that were assigned to the text snippets. So we used that information. We saw in some of the URLs we had text coming from Wikipedia, whereas in some of the URLs, we had text coming from another domain called Simple Wikipedia. And we had no idea about that there is another Wikipedia called Simple Wikipedia. Okay. And then we started looking into what is Simple Wikipedia. And then we found out that Simple Wikipedia is a sister project of Wikipedia, where the same information is written in a much simpler form so that everyone can understand and things like that. So for instance, if you look at the Ford Pinto, the third row, so if you look at it, you will see the vehicle was marketed under Ford Motor Company in the States and Canada. It was made from this year to that year. All simple sentences, no complex sentences, no complex words. Whereas when you look at the other example, you look at it as the smallest American vehicle, the Pinto. You see, it's already a complex sentence because it has a comma, it has a class which supports another class and things like that. So
that makes sense. Yeah.
So this is something that we identified, and then we thought, okay, we have to use this data to pre-train our model. On the other hand, we have to remember that our competition data is trained for a regression task, whereas this is not a regression task. So we used a loss function called ranking loss. So in PyTorch, we have an implementation already in the library. So what it does is, it takes two scalars and then compares which scalar should be scored higher in comparison to the other scalar. Margin ranking loss. Yeah, the first one. So that's the thing. So it can take the values x1 and x2, and then it will take the value. So x1 and x2 are two scalars, and then y is the ground truth, which says whether x1 is greater than x2 or x1 should be lesser than x2 or whatever it is. So we identified this. When you look at this is something similar to, you take the simple Wikipedia text and find out a readability score. Let's say that is x1. You take the normal Wikipedia text and find a readability score. It is x2. Now you are pretty sure that the simple Wikipedia must be easier than Wikipedia. So you know the target value y as well. So this is how we pre-trained our data a lot. So what happened was, we tried this at the beginning when we joined together as a team. We tried it, but this did not work. We were going crazy. Why? This makes sense that you pre-train on so much large samples, because Wikipedia and simple Wikipedia, they had more than 100,000 pairs that were present in the data. So you train it on 100,000 pairs, and then you further train it on the competition data. The result should be way better, but that wasn't the case, and we did not know why. What happened was, 2 days before, so we parked it. We did not use it any further. 2 days before the competition, when we ran out of ideas, and I was going around these discussion forum and commenting on people's posts like nice, really nice work, looking forward to the end of the competition and things like that. Kurupikal posted something, and then I went at looking at Kurupikal's old post, and then I saw in one place Kurupikal says this technique kind of works well for him. So and then I was like, okay, if it works for that person, it should probably work for me as well. Then we looked into it, and then we got it working on the last day of the competition, and then we submitted it.
I can imagine the group, the Slack conversations that must have been going on, and the adrenaline you must have had.
Yeah.
Awesome.
So the change that Vignesh did on it to make it work was to match the statistics of this data set with the distribution of the given data set, like the sentence length, the number of words, stuff like it. Like the characteristics of the text were matched, and then he pre-trained on the data to make it work. So after the end of the competition, we found a better method, which was one of the other solutions. I think I'm not sure who did it, but the person used sentence transformers to do similar matching, and he got way better results. Yeah.
So probably if we would have spent much more time doing it, then we could have done better. But this is every Kaggler's regret. If we had more time, we would.
Yeah. I mean, yeah, this made a very good difference in the leaderboard, because pre-training on the same task always helps very much.
Yeah, I can imagine. That makes sense. All right, moving forward in your solution, and that's one thing I really love. That's why I really want to do these deep dives, is because we learned. I didn't think of this technique ever before. Like, you could have an external data. My intuition would be just train on that. Just throw the model at that, you could. But no, you need to match the stats of it. I didn't think of that extra step. So thanks for sharing that. Okay. So I'll keep moving forward. So these are usually, for anyone who's gone through a solution, these are the standard boilerplate. I'll keep scrolling, and please feel free to point out any things that you want.
Yeah, sure. So one of the things that Shahul and I were very particular about was about the cleanliness of the code. We really wanted to make sure that our idea was we run so Shahul runs experiments on the base, and he tells me which works, which doesn't work, and I replicate the same for large. For this to happen, we really had to make sure that we had been using the same environment. We use the same code, we use the same random state, we use the same version of the libraries. Everything should be exactly the same, just the word base should be changed with the word large. So this is something that we were very particular about. So we spent over, I don't know, like 2 weeks, and it took, I don't know, like 70-80 commits to make sure that our code was robust. So at that point in time for the competition, we just joined together for the last 1 month together, and we already spent 2 weeks just on making the code perfect. So we already spent a lot of time, but we are really happy we did that, because that made sure that we have a very good experimental setup where we can replicate each other's work. I can just send the configuration file, and I can be confident that Shahul will exactly be able to replicate the same thing at any point in time or something like that. So this code snippet is also an example for it. It was like quite documented and things like that to make sure that we are aligned with each other.
This is one of those rare Kaggle code instances where you can see comments as well, and not just like one single line comment, but proper dog string. So
yeah, exactly.
Okay, so looks like this is all just setting up the data set. You're doing the things you need to do for Torch. I just want to point out that one thing that clean code really makes it easy is if you're doing a live stream here, this is the first time I'm reading your code, and I can just nod to it and like skim past it because and it's not quite common in Kaggle competitions. You have to spend some time to understand solutions sometimes.
Sanyam, I want beautiful stuff on my screen. So that is one of the main reasons why I like 1DB as well. I don't know. For some reason, it is so beautiful when you look at the dashboards. You feel proud of yourself that, wow, I created this and this looks so nice in the dashboard. Like even today, I was really surprised. We were creating a 1DB report as well. That's a gift that we gave ourselves because we wanted to beautify our solution even more. And the results, when you look at the dashboard and everything, no work, no time, it looks beautiful. And for me, it is very important to have something pleasing. So the code, the dashboard, everything is a consequence of it.
Yeah, I can't take credit for that. I wasn't remotely involved in that. The team has come up with it, but I'll make sure I pass that feedback. Thanks. That really makes me happy to hear that.
I'm pretty sure I'm not the first person who tells that 1DB looks beautiful.
Really appreciate that. Thanks for that. Okay, so I think I also want to point out the attention trick that had come up. I don't think this is it, but maybe if I go back to your solution write-up, it should be there.
No, I have also, no, Sanyam, you can go down and you will see, see something weird
right.
that we did. No, you can even go down, still down, still. Yeah, here it comes. So we made pictures of how it works as well.
This is perfect. Awesome. So this is the explanation
maybe we will,
of. Sorry, please.
How the attempt. Yeah, maybe we will go to the tokenizer and maybe Shahul can explain the tokenizer and then we'll go to the model.
Right.
Sounds good. Going back to the tokenizer.
Right. In this competition, yeah, as in like we used Roberta. Roberta was the only model that we used. We used Roberta base and large, and the tokenizer we used the default Roberta tokenizer for converting the text into the input in which Roberta takes it. So Roberta needs input IDs and also an optional attention mask, which specifies if the actual token is there or not. So this is normal tokenizer that Roberta uses. Yes.
Got it.
So from the Roberta tokenizer, we get two outputs. One is the input IDs, and then the other one is the attention mask. So what happens is basically the tokenizer takes list of text, and then it gives out input IDs. So input IDs are the vocabulary indices corresponding to the tokens, and the attention mask basically tells you whether a word was present there or a pad token was added because of the length constraints. So that's it.
Okay, that makes sense. All right. So now comes the exciting part for at least people who enjoy modeling.
So maybe let's start from the mask and attention head. Then it's or the next one, mean puller, last hidden state mean puller, because it each one builds on top of each other. So if we start from here, then it's easier to understand that. So basically what we do is, Sanyam, can you highlight the self.roberta line? Yeah, exactly. So this is the first thing that we do is we load a pre-trained transformer model from Hugging Face, and we can assign a dropout probability to the layers of the transformer. So this is the most basic thing that all of us start with. And then the transformer takes in the input IDs and the attention mask, and then it gives out two inputs. One is the puller output, two outputs. One is the puller output, or it gives you the last hidden state. So we did not use the puller output, but we use the last hidden state, because of some reasons that I will explain you later on. Whereas the last hidden state is basically, now we can go to the diagram that I have drawn below.
Yeah, this is incredible.
Okay, we will the latest people you can ever. we drew something on the notebook, scanned it, and put it here. Anyway, so what happens is, what happens is a batch of inputs consists of on the right. So a batch of inputs consists of text, and each text has been tokenized, and you get tokens corresponding to it. When you look at it in a matrix form, what happens is the number of tokens is the maximum number of tokens that can be present in the batch. And then the input dimension is basically the hidden dimension that comes from the transformer. So each column corresponds to a vector that is corresponding to a token. So basically this, you can think of it as if you gave a single document, you tokenized the documents, and for each token, you had a word vector. And when you concatenate all the word vectors together, it becomes a matrix. And that is what you see over there. So it has the shape, hidden number of tokens as the number of columns, and input dimension, which is the hidden dimension of the transformer model. So for instance, for Roberta base, the hidden dimension, which is the input dimension in this case, is 512, whereas for Roberta large, it's 1024. So if your matrix, if your input batch had maximum number of 200 tokens, then you will have a matrix of 1024 by 200 to represent that particular text. Okay, so that is what you over. And then what you do is you that is what comes as output from the transformer. Now can you know Sanya above the matrix W? Let's explain what matrix W that you see on the left. So the matrix W is basically the attention head. So what you do is the matrix W is of dimension, input dimension is the number of columns, and the attention head, hidden dimension. So the attention head can also take a hidden dimension. So when you do a matrix multiplication between the attention head W and last from the transformer, you get some output. So the output is what you see down as attention head, hidden dimension, number of rows, and then the number of tokens. Follow? So that's the output from the transformer. And then in step 2, you take that output, and then the attention head has has another single vector that runs through the entire output. Okay, and then a simple multiplication, and you get a simple vector corresponding to the text. If you think about it logically, what it means is this attention head is basically trying to learn weights for each token in the document. So the attention scores that you see is a weight that the model has learned. Exactly. The attention score is a weight that the model has learned corresponding to each token in the text document, which helped the model to do a better regression. That's it. So for instance, so that's it. As simple as that. Basically, you're trying to learn feature importance vector. Okay. And then finally, you simply do a linear, the last step is where you take this attention score and you take the last hidden state from the transformer, you do a linear combination between these two things, and then you get a vector for the document. So what you're basically doing is you're trying to learn the feature importance for each feature in your document, where the feature is word. So you are learning the importance of every single word that is present in your document, and then concatenating them together into one single vector, which will represent the entire document. This is basically like doing a TF-IDF thing.
Got it. Yeah.
So this is how the attention head actually works. Now, if you look into it deeply, you will realize there is a big problem with that. The big problem is that at the end of the document, based on the batch that a particular document fell into, you will have PAT tokens corresponding to it. Now, you are assigning attention scores to the PAT tokens as well, whereas you know that the PAT tokens are not at all important. You know that the PAT tokens are not at all important in your final. So what you basically do is, depending upon the batch size, which batch, so you will have a representation for each document, which will change based on which batch it fell into. So this is not okay. So we realized that, and we changed it based on masking. So what we do is we take the attention scores, and then we take the attention mask, we superimpose on each other. So we make sure that the attention scores corresponding to the PAT tokens is very, very low. So the PAT tokens get almost zero importance in making the decision. So this is the trick that we used, and this helped us climb up the leaderboard by a lot.
That makes sense.
And Shahul?
Yes. I think it's I think it's clear from your explanation.
I always say, like, I'm the benchmark. If I can understand it, anyone can understand it. So far it was clear to me.
Okay,
also real quick, Vignesh, we might run 15 minutes over the time. Is that fine?
Yeah, that's fine. Of course. Yeah.
Thanks. All right. I'll try to wind up quickly. But so far things make sense. There's this problem. We've come up with this scores, these attention scores, and to address the padding problem, you superimposing attention mask over it. So far it makes sense, and all of this is being done on top of Roberta.
Exactly. Yeah.
Okay.
So basically, this is how the model has been designed, and
great. All right. Another trick I want to point out is also the layer-wise learning rate decay. This was shared in FastAI at one point in time, but I don't think it's come out of that community a lot. So maybe I can explain it at a higher level. So whenever we apply learning rates, they're applied to the complete model. Sometimes, at least this is done in FastAI, they group the layers into certain buckets, and they apply different learning rates to it. So as I understand, that's what's going on here as well. We've created this groups, and we're applying different learning rates to them. Am I correct in my understanding?
Yes. So this idea has been there for a long, and with this competition, I think it became very famous because Rohit Singh published a kernel with all these techniques, which included differential learning, right, for different transformer blocks. So what happens is that different layers or different blocks in the whole architecture learns different information. So when we assign one specific learning rate to the whole architecture, it might not fit the model. So the idea is to assign different learning rates to different part of the model according to the layer, or according to according to the layer, so that model learns speedily. So it is assumed that the lower layers learn more general information, and as we come down towards the bottom, the model learns more specific information. So at that point is where we need a faster learning, right? So that's the basic idea. And with this competition, I think it became pretty famous due to this kernel of Rohit Singh.
That makes sense. Thanks for clarifying that. So I'm quickly reading through the code and scrolling down and trying to understand and point out the things that are interesting. So far things make sense. You set up a scheduler, you've updated the config, because unlike me, you are really strict about the standards of the code. I don't do any of this. So I'm just intimidated by how much effort you all have put in there. I think I'd like to understand this as well, because this was a part of your write-up as well. So if you could please explain what's going on here for both of these.
Yeah, sure. So basically, when you treat a problem as a regressor problem, which is what the competition data was, you on the left, you see you read the text. You send the text to a vectorizer. So, Samyam, can you point your pointer to the text regressor? Yeah. So yeah. So you take a text and then you pass it to a vectorizer. The vectorizer can be anything. So it can be a basic TF-IDF vectorizer, or it can be a Hugging Face transformer or a Spacey vectorizer. It doesn't matter. You get a vector that represents the piece of text, and then you have a regressor. A regressor again can be a very simple regressor, like a linear regressor or an SVM regressor. So a regressor which takes the vector and spits out a scalar as a prediction. And then you see how well the model has learned based on the ground truth. So you have a prediction, and then you have a target, and you compute the root mean squared error, and then you update the model. So that's how it works. Whereas in a text comparator approach, what we do is, instead of learning the readability prediction from one single input, you do it from two inputs. So on the right, you have text 1 and text 2. So you do the same process like what you do on the left. You take the text 1, pass it to the vectorizer, you get a vector, and you do the same for text 2. Whereas instead of sending it to a regressor, you send it to a comparator. The comparator, what it does is, it tries to take both the vectors and then see which of these vectors is easier to read, or which of these vectors is difficult to read, or whatever it is. And you compute a ranking loss in accordance to it, and then you update the weights of the model. So this is how the text comparator works. So basically, we used the text regressor problem to train on the competition data, whereas the text comparator approach, we used it for the external data. And this helped us leverage over, I don't know, we trained on 20,000 more samples, just because we used the text comparator approach in comparison to the 3,000 samples so we trained on more than 7 times the data, and of course had a huge benefit.
Yeah, this is really incredible. Again, as I said, like, as someone who just reads solutions and not understands them so sincerely, I would just assume you take a data set, throw your model at it, you're good. But this really explains it, that okay, you were, first of all, you pre-process the data set as well, and then furthermore you also created this comparator model that was comparing those two texts and predicting the difficulty ranking. That's incredible.
So
I think that summarizes the solution.
And we have a WanDB dashboard link at the bottom.
Sure. My keyboard has died because it needs a charge.
So, Sanyam, can you quickly go through this dashboard and
yeah.
Can you guess how much time we took to do this?
I don't want to disrespect you, so I won't guess the time.
I will tell you. This is the first time that we are using the WanDB report, and we did it in less than 10 minutes. Like, it was incredibly easy.
Don't tell my coworkers. I've been skipping on it because I assumed it'll take like 10-15 hours. But I'll do something this weekend then.
No, it's super easy to use. Anyways, can you go to the second point, because that's one of the interesting points that we want to discuss with people. Yeah, here. Okay, yes. So if you look at this graph, you will see on the x-axis it's the iteration number. On the y-axis it's the validation score, which is the RMSE score. If you look at the blue line and then the brown line, they come from two different experiments. We evaluate every 10 iterations. And when you look at this graph, Sanyam, you will understand why most people evaluated every 10 iterations, because the performance drastically changes every other iteration. The performance just crazily changes every other iteration. So when Shahul and I looked at it, we were really, really worried that transformers are very unstable. The way how transformers are trained today is very unstable, and so people evaluate every 10 iterations because it's like throwing 1,000 apples in the dark, like you are shooting in the dark to get an apple or something like that. We did not want to do that. We were very, very uncomfortable doing it. So we spent, I told you, right, we spent over 2 weeks in strengthening the code. When we did that, the other half of the time, we tried to figure out the basic reason. We tried to identify the underlying reason why this happened, because I saw in most of the other top performing solutions also evaluated every 10 iterations. We were one of the very few solutions who did not do it. We evaluated at the last. We trained for 3 epochs. We saved the model at the 3rd epoch and we used it right away. We did not use any intermediate evaluation at all.
Gotcha.
The reason is because of 2 reasons. The first one is the experiment 15, which is the blue line, comes from a model that was trained with layer-wise learning rate decay. And it was also trained with no dropout. Apparently, transformers don't like dropout or something like that. We did not dig deep into the reason why that was happening. But this was very weird to us, that most of the trainings that were happening were unstable. And this is one of the reasons why people had to train 100 models and put it in an ensemble, because of the instability that was raising in the training. But we were uncomfortable. Shahul and I, we both come from industry. For us, training 2 models is already like, no, just one model, something like that. Yeah. We were thinking, should we also have a base and a large in our ensemble? We were thinking, no, we'll just have one or something like that. We were that crazy. We were, because we don't believe in smoothening with an ensemble. So this is one weird thing that we identified. And the top, if you go to the top, you will see another graph. This graph. So these are identical experiments, completely identical experiments, but completely different results.
Just because of the seeds?
Exactly.
Yes.
Interesting.
I mean, even this even reflected in the LB, in the public LB, and people were going crazy on it. I think, we believe that the root cause of this issue is, the number of samples to train on. It's just 2,500 samples.
Yeah.
After what we get after splitting validation, train and validation. So yeah, that can be one of the root causes. But yeah, this if keeping everything same, just the difference in random seed caused this huge difference in training. And yeah,
I'm sorry I'm laughing at it, but it's quite funny. I'm sure it took a lot of effort to understand this. And I just wanted to point out, Shahul, you said you were interested in MLOps, and be it 1DB or any other tool, that's what this highlights. Like, as someone as me who hasn't gone through this competition or hasn't understood this, I can just look at this graph and understand, wow, this is really incredible why you all were doing this. And it makes easier to understand experiments, which is where the real knowledge lies. Like, no one would know that dropout isn't something that you wouldn't apply to transformers. It's a standard technique, right? But looking at this graph, it's obvious you shouldn't be applying dropout here.
Right, we cannot generalize it, but yeah, for this competition, for this data set, for maybe it can be because of the number of samples. Dropping dropout was one of the magic techniques.
That makes sense.
So
these two, please go.
This was a result from pre-training on the external data. Again, the pink line comes from a pre-trained model. So you pre-train on large amount of external data and the performance worsens. Whereas you don't do any pre-training, the performance is again, all these things are like crazy. But when we submitted it on the public LB, we saw that it reversed. So
it
pre-training
correlated
way ahead. Yeah. So what happens is the LB and the CV had no correlation again. So that's one of the other. So this is one of the reasons. So we see that the CV doesn't improve, then we don't end up submitting. But we had some few models, we had few submissions left over, so we submitted, and then we saw, oh no, it does improve. So these are all certain things that we learned, and yeah.
This one isn't loading, so I'll skip that. But sorry, what does SWA stand for?
It's stochastic weighted averaging. It's a state-of-the-art technique which we use with optimizers to get better generalization while training. So yeah, we used it. I mean, it has been there since a long time, but this is when I got to use it correctly. Yeah.
Okay. All right. I think we covered this dashboard. Let me go back to the solution real quick. I believe we've covered everything.
Yeah. It's the same. I think I repeated it twice. Yeah.
Incredible. All right. I quickly want to point the audience. I know we run out of time. We ran overboard actually, but I'll quickly point the people to your profile. So if you go to Shahul's profile on Kaggle, you can find his LinkedIn link off there. This should take you to his LinkedIn profile. Make sure you connect with him there. He's also on Twitter. Let me see if I can find that tab here. But if not, I'll share the link across later on. And same goes for Vignesh. If you hover to his Kaggle profile, you can find his Twitter and his LinkedIn or there, his website as well. And make sure you connect with him on there. So his Twitter handle is @tweettv Baskaran, and for Shahul, it's Shahul ES 786. I just wanted to point those profiles out. Anything else that I missed where people can connect with you?
No, Sanyam, we just really have to thank you for organizing this. I know it's late in India, but thank you very much for organizing this in a weekend. So
I'm grateful to you that you're giving me your weekend. Shahul is in India as well, and I know he's at a co-working space. I'm doing it from the comfort of my chai studio, so I can just go to the bed right here. But thank you so much, honestly, for everything you've done for the community as well, Shahul. You've been sharing so much incredible stuff, and for sharing your journey today, both of you. Thanks for your time. I learned a lot, and I'm sure the audience did.
Sure. Thanks for having us.
Thank you.
Yeah, thank you.
Let me make sure I end the live stream.